This conference will now be recorded.
So welcome everybody, we do have a number of newcomers to this meeting, which is great. Welcome. So I'm just going to take a couple minutes to give a very quick history of this group, how we got to where we are today, right? This group being the Agriculture and Climate Cluster. The ACC is one of many clusters of ESIP, right? The Earth Science Information Partners. And cluster is the most common form of collaboration group within ESIP. And my definition is basically two people with a common interest. Very simple, my definition. So the ACC began in 2013 to focus on actually agriculture and climate, involving the science, technology, and of course data. And our activities evolve over the years. We began with USDA, the Long-Term Agroecological Research Network of ARS, and then that led to their climate hubs, and that led to the U.S. Climate Resilience Toolkit hosted in NOAA, and we put on several workshops to generate case studies to contribute to their library or their database of case studies. And it was thinking about how a user can better get information out of a database like that led to our recent focus, recent being the last 2-3 years, but particularly this past year, on data to decision. How do you trace data to decision or decision to data via concept maps, knowledge graphs, ontologies. And this past summer at the ESA Summer Meeting in July, we hosted a couple sessions on this topic. And since that meeting, in the weeks and months after, we tried to organize a program of meetings and speakers that's around that, in that space, and leading up to, and right now we're preparing for the Easter winter meeting in January. We will be hosting or proposing to host a session on that general subject matter as well. So that is a quick history of how we got to doing this kind of working on this in this space, and also, of course, today's talk be given by Matthew Lange also in this similar area. So I'm going to pass it on to Paco, who's a managing partner at Derwent, to introduce. Well, Paco has a few slides first, and then he will introduce the speaker, Matthew Lange. And one last thing, please mute your mic if you haven't done that yet. Okay, thank you. Paco?
Thank you very much, Bill. Let me go ahead and see if I'm sharing this appropriately. All right, great. Thank you very much, Bill. I appreciate. And today it's an honor to get to introduce a friend who I think has very much to share here for this group. Dr. Matthew Lange is principal investigator at IC Foods at UC Davis, and they're building out a Internet of Food knowledge graph. You'll hear much more about this, but I just want to stress I've been very impressed with this work to connect together the really important linkage between what's going on in agriculture, all the way back, tracing back to the genomics of it, on through production of food, all the processing, on through the implications of our diet to our health, and of course all the feedback loops in between. And for what it's worth, I got to meet Matthew through an open source project, and that always bodes well. So one of his students was using a project I was working on, and we started talking and realized we should be talking more. One area that we've been collaborating on some is I'm involved with the Knowledge Graph Conference, and Matthew's been helping to curate and also one of the main hosts for what's called No Food. It's a series the third Thursday of every month. That's a webinar meetup, but basically exploring these topics. And also, I'll put in a plug, a couple of related conferences coming up about knowledge graph in industry. One is Knowledge Connections coming out of London in November, and another is the Knowledge Graph Conference out of Columbia University, New York City area, which will be next May. And so having said that, without further ado, it's my pleasure to get introduced Matthew.
Thanks, Paco. Can you all hear me? No?
Mhm.
Getting good. Some nodding yes. That's great. And I guess let me make sure that I can share my screen, the appropriate screen here. So I think I need to be the presenter, and sorry, there's a permission thing here. Just give me a minute to allow. Looks like I need to allow this to record my screen. Goodness, go to meeting. It says it can't work until I stop and restart it. Let me just try it anyway. Yeah, it looks like it's going to work fine. Can you all see my screen?
Yes, we can.
Okay, great.
Yes.
Terrific. That's great. I'll just go from here. I represent IC Foods, which is the international. Now we used to be called IC Cubed Foods, with a little 3 up above the C. Excuse me. But then people started calling us IC3. And so I stopped. I took the 3 out, since there actually is an IC3 already. And it's really the food that's the most important. But it is an acronym for the International Center for Food Ontology, Operability, Data, and Semantics. It's also an international conference. It's also an international consortium. So hence the cubed C. This is a graphic. In fact, it's the graphic that got me the initial seed funding for IC Foods that we got from an institute at UC Davis that was ultimately funded by Mars Food Company. The idea being that we can build ontologies and not just ontologies, but connected data sets across the entire food value chain, from precision agriculture to precision health, and tracking all kinds of metrics in between related to our behavior, activity, sleep, stress. And keep in mind, I'm very consciously saying here health, not disease. What we eat and how we eat it. This includes things like, well, I have activity up here under health. Of course, related to eating. Also, you see on the far right there is rituals. That gets into cultural aspects of food as well. And all the various ways we process food and how that changes its structure and bioavailability of specific nutrients. And I'll get into some of these in a little bit. I'm not going to go through all of this. Let's suffice it to say that this has implications for individuals, the things they're exposed to, what that means for them over time. We can group them. We can essentially look at trends for groups as well as individuals, and that ultimately has impacts for trade and economics. And it needs to be built on shareable, reusable, scientifically valid infrastructure. And I'll get into some of the details for how I think that needs to happen. One more thing before I leave this slide. This list here that starts with omics at the top, panomics, proteomics, metabolomics, genomics, you name it. We have what is essentially a new way of doing business around omics. which has for many years resulted in science being focused around drilling down into the omics. But I think we have an opportunity to integrate this kind of science. We also have ways of sensing that we never did before. So we can sense the world in terms of the gyroscope and the GPS and accelerometer in your phones and get a pretty good idea of what you're doing. We can tell whether you're walking, biking, in a car, on a plane, in a train. So we have new windows of opportunity to inquire about how people move around and do specific things, and various other ways of tracking and assessing mood, including ecological behavioral assessment, sending texts to people randomly asking them the mood that they're in and how they're feeling during the day. Various ways of aggregating information that previously were not available to scientists, but now they are, thanks to the ubiquity of cell phones. So you'll find this out on our icfoods.org. It doesn't matter whether you put the dash in there or not. It will resolve to the same place. So we were recently spun out of the UC Davis, and we are now a standalone nonprofit. And we collaborate with academic governments, NGOs, and industry partners to build the Internet of Food and the Semantic platform underneath it, and which is essentially a backbone of connected ontologies. You'll see down on the bottom there, my name is Matteo Lan on social media. Feel free to hit me up and connect with me there. I'll also leave my, I put my email address in the person registration there for the call. So you can copy my email address from there. So we are in a different state. We did spin out. So this was the original team at IC Foods. My co-investigators, Tom Tomich, who led the Agricultural Sustainability Institute, Jim Quinn, who led the Information Center for the Environment, and Nick Anderson, who leads the health research at the UC Davis School of Medicine and Health System. So we truly do have expertise going from the environment with Jim Quinn to agriculture with Tom Tomich, all the way to health with Nick Anderson. And my training is as a food scientist. These are some of our former students, alumni. Particularly worth noting, right below me is Courtney Riggle. She was the one who helped me do the lion's share of writing the original grant proposal. And now we have a new board as icfoods.org. Some of you at NASA may know Ezine Uzo-Okoro. She's also with NASA, she's Chief of Small Missions. Rochelle is an attorney who's works deeply in bringing broadband to rural areas, and Courtney I already mentioned. So our number one mission, and this is taken from our articles of incorporation, is to assemble experts together, research, design, disseminate technologies and ideas to stakeholders for an Internet of Food to address the most pressing problems. Now, we see this really as, not doing any good unless there's broad adoption of coordinated, standardized, and scientifically validated and semantically linked architectures that are both human and machine readable. And that this presents business opportunities across the food value chain. This came out today, this morning. new study of the world's 100 most sustainably managed companies. The only food company that made it in there was Nestle, which is kind of a shame because there are big companies like Mondelez and Unilever who make a lot of claims around sustainability, but somehow they just didn't make this list. This was in Forbes, by the way, in case you're interested. I'm sorry, I did not put the link there. So if you've seen me on YouTube or something, you may have heard me say the singularity will happen through food. Now, some of you who are mathematicians are probably saying that doesn't make any sense at all. That the singularity is about either we're going to talk about mathematical models or we're going to talk about humans and machine computational levels being to the point where we have a super intelligence. So what the heck does this mean? The singularity will happen through food, and where do I get off saying that? Well, let's take a look back. It wasn't that long ago that Mark Andreessen said that software is eating the world, and he wasn't too far off. Basically, that we can have build software to automate and do lots of various things. It was more recently that Jensen Huang basically came along and said, yeah, okay, software may be eating the world, but AI is going to eat software. Now, he predicted that healthcare and autos are going to be transformed by artificial intelligence. And, he's probably right. But I think that there's something more immediate and pressing that we should all be paying attention to, and which has basically been largely given short shrift by the tech industry until I would say the last 2 years. So just for emphasis, the singularity will happen through food. It not is food, it's through food. Why is that? Well, if we think about 5 nines of AI, that is, if we want 99.999% accuracy for artificial intelligence, well, we need 1 trillion points of data. Well, if we have, let's just say 1 billion active users, which Facebook, Google, Apple, they can all claim this, then we need roughly 1,000 actions per person. If we assume, and this isn't totally true, but we can assume roughly 3 meals per day, that means it's really less than a year before we can have 5 nines of AI around food. But what we need is we need a way to essentially exchange models, to exchange information. Of course, that happens then with ontologies. If we want to talk about attributes to our models, what have you. So let's take a look at how we can do this. And of course, it's not just eating, right? It's growing food, it's processing food, it's doing all kinds of things related to food. In fact, we have several knowledge domains. Just sort of look back in this from the original slide and think about, we've got climate and environment and landscapes. How do we know what to plant in this particular plot of land? And what will be the recourse for doing that over time? How much food of that thing can I grow in that plot of land? How can I process it to be safe and healthy? And that alters the phenotype of the food. And we have standards and quality. There is a large corpus put out by the UN FAO that defines standards and quality. And then we have, of course, packaging, distribution, and new technologies like blockchain ledgers to track these things through the supply chain to the purveyance and habits of consumption, right? So I won't belabor the point, but you get the idea. one of the things that IC Foods is engaged in is an NSF project called Developing an Infrastructure for Smart Regional Food Sheds. Basically, with this project, we want to answer what do we eat and where does it come from? What do we produce and where does it go? And what gets wasted along the way? So that we can ultimately understand and optimize the food system. So one of the things that I'm sorry? Oh, I thought I heard somebody ask a question. Okay, one of the things that we're doing here is bringing together at a regional level, all of the stakeholders in the food system to understand what data sets they have. And I'll get into a little bit more detail about that. What data sets they have that could help us answer these questions for a particular region. We also have a conference, and this is, I mentioned earlier, this is just an example of one of the days of our last conference last year, where we're looking at the grand challenges of the food system and how we can address some of these challenges, particularly with software, with hardware, Internet of Things. So I really see the Internet of Food being partially Internet of Things and partially semantic web of food, as well as a variety of other aspects. But those would be the two largest aspects of the Internet of Food. Certainly developing a transactional infrastructure would be part of that as well. Down here at the bottom, you'll note that we have two speakers related to food safety. As a food scientist, I have to say that, foundational to my training is that if food isn't safe, well, then it really isn't food. So even if it's unhealthy, if it's not safe, at least in the immediate term, you're in trouble. So we can actually look at food in a way where, we often talk about the phenotypes of individuals or of bacteria. I say that we can phenotype foods. I can phenotype, if I can phenotype a woman based on some of the milk that she produces, well, that milk is a food for a baby. So I could phenotype the milk. Sometimes it has certain amounts of fat. Sometimes it has certain amounts of oligosaccharides. So foods have a phenotype, and I can extend that. I can say lasagna has a phenotype. It's got multi-genome. So it's not quite an organism, but I would argue that it has a phenotype. And if any of you would like to wax philosophically about this concept with me, I would happily engage. So we have actual components, and then we have properties. And we also have this class down here called organoleptic property, and this is the flavor. I'll just call it flavor as a catch-all. And flavor actually is a wicked problem, which I probably won't get into today, but suffice it to say that it's combined from the visual components, the sound components, the and all of the BCP, the biological, chemical, and physical. So we have this concept of food phenotype. I'm sorry, I think there was a, nope, I guess not. Okay. We have this concept of a food phenotype that is really sort of at the molecular level that we can drill down to. And this phenotype will actually change through time, right? So I have the biological, chemical, and physical array of properties, and through time, through processing, and through the environment that it may be exposed to, I get a new set of biological, chemical, and physical components and properties. And as a result of that, the organoleptic property also changes. So we can measure that change with sensory experiences and how we perceive food. This also is not just around flavor and aroma, taste, but also the way something sounds, whether your apple is crispy when you bite into it, how shiny something may be, what have you. So we've got this idea of a food phenotype, but then that food phenotype is altered by processes. So we can begin to develop ontologies around those specific processes, whether they're production, transformation, distribution, or even the consumption process. Sometimes we eat things that have been consumed by other organisms. In fact, the most expensive coffee in the world has already been consumed by a civet and has been excreted in its poop, and supposedly it's very good. I have not yet had poop coffee, but I'm sure it's delicious. So we have these production, transformation, distribution, and consumption processes that we can build ontologies around. This is an example of a decorticating process, right? The removal of the outer layer of something related to food. And then we can link processes and data about food processing and the sensory experience that we may have after it goes through a specific process, as an example. So we've got food phenotypes, we've got processes, and then we've got the agents and the actors that are engaged in those processes. And I'll get into a little bit more detail about those agents in a minute. As I mentioned earlier, as part of our Smart Food Shed work, we're also building ontologies for linking expertise in the food system so that we can also collect data sets and know who to go to find specific data sets. Right, so we have essentially ontologies around the food production industry, all the various types of farming. We have ontologies around the food processing industry. We have ontologies around the allied industries related to food processing, like equipment manufacture for food processing. So finally, what we have here, we've got the processes, we've got the actors and agents and their equipment engaged in those processes. And then really we have the LC issues, right? And LC, ethical, legal, social, but I've also added business, health, and environment. Now, maybe those three are all part of social, but I wanted to sort of call them out because when I think social, I think of things more like food justice, food equity. So I wanted to also call these out. So there's an opportunity here to examine the issues that result from how these agents interacted with these processes to alter these food phenotypes, right? So if we sort of go down this track, we can phenotype not just the bread or the lasagna or the milk or the croissant, but we can phenotype the dough. And genotype the dough. In fact, I've got 3 different kinds of dough in my refrigerator right now with different cultures of yeast and bacteria growing in them. We can phenotype the flour that dough grew on down to the particle size of the flour, which varieties of wheat or other grain that it came from, what have you. Of course, the plant. And I would argue that we can even actually phenotype a field. Now, maybe that's not the most appropriate word for how to characterize a specific field, its proximity to water, its climate, microclimate, what have you. But I think you'll understand the message I'm trying to convey here. Now, this value chain that happens here, and holds promise for us to develop new ways for scientific inquiry. You know, we know that Google and Facebook and Apple and Microsoft are constantly running A/B tests in user interfaces to us all the time. They are doing science at a scale that university professors dream about doing. Well, if we have an open and traceable infrastructure for food, then we can begin to do those types of science as well. So those issues that I mentioned in that biggest circle in that framework, we have developed an ontology around. Not just issues, but essentially the indicators that describe those issues and can classify the degree to which they are being addressed or ameliorated or improved. This is a graphic of essentially issues linked to their indicators and linked to essentially integrated issues. The red dots would be the integrated issues. The blue dots would be the specific component issues, and the green dots are indicators for how you might be linking those issues. Now, we can also link these things not just to issues, but to goals. This is my friend Pierluigi Buttigieg, and he is a creator of the UN SDG ontology. And he is also one of the creators of the environment ontology, which I see has been linked to your suite ontology suite. So maybe some of you know Pierluigi. This is Damien Dooley, another heavy hitter worth calling out on the food on ontology. So food on, Damien and Pierluigi and I and Chris Mungle, who was one of the founders of the gene ontology and is perhaps one of the most famous ontologists in the world, got together and said, we need to make a food ontology. And Damien has really sort of carried the torch and done a lot of the heavy lifting around building food on, bringing together several vocabularies. And I'm happy he is there to decide how to classify a mature baby pea, because that is beyond me. Not only is he classifying things like mature baby peas, he's actually done a great job of linking together, since he is in a lab that is focused on food safety. He has done a great job of linking food to the specimen collection process, material analysis, and ultimately nutrient availability as well. We have worked together on a project for the USDA to redo the food composition database for the USDA. And this is some of the larger picture of how some of these ontologies link together. Just a list of some of the other ontologies that are also part of the food ontology ecosystem. There actually are too many to list here. I have called out the environment ontology there in the top left, ontologies of biological attributes. There will soon be this, I think, food attributes and organoleptic attributes. We're still talking about how to link that to a culinary ontology. Various aspects of agronomy, crops, plants, plant traits, and the food processing ontology is really just under heavy development now and ripe for change. Oops. Now I did look through around ESIP a little bit, and I noticed that there is a deep neural network for recognizing crops based on spectral characteristics. And I was pretty excited to come across this. And then I opened the data set for this, and I was a little disappointed to find that the crop was just straight text and wasn't actually an entry from the crop ontology, which would be great. So maybe that's an easy win, something that we could do together to align some of your existing assets with some of these ontologies. As Paco said, and I'll just give a second plug here, we have nofood.live. The website is not .live yet, but this is a sneak preview of the website. It is a show, a recurring show that will happen once a month. We are in the process of post-production of the first episode, and really we're there to talk about knowledge graphs, how to make them, why to make them, and how we can make the world a better place because we're making them. And this is just a brief list of a few of our partners, and would be happy to have your logo up here as well. So with that, I will end my presentation and say thank you for having me, and open it up to any questions, I guess.
Thank you for that presentation. I have a question, but I'm going to get in line because Bill will help moderate. So I will I'll put up my hand first, but Bill, I'll let you decide on the order if there are any other questions and how we should do this.
Yeah, maybe just a general solicitation to the entire group if anybody has questions right now before Brian gets his turn.
Could you guys imagine that I would have a question?
Oh no, Dan. Here we go.
I don't want to disappoint with I want to disappoint with my question, as is normal, I guess is the way I should say it. But Matthew, thank you. That's actually, it's a really interesting project. One of the things where I started to get confused was as you were talking about the ontology for a specific food, and you called out the things that could be included for lasagna, and then it got down to the smells. This suggests that one food could never actually be formally characterized, I guess. Is something that you would probably understand and might have it in your plan. And I was wondering why that would be in the plan if you can't come to a specific characterization for a very specific, the lasagna in front of me could never actually be represented. Is that a fair question?
I wouldn't say that it could never be represented. So if I said that, then I misspoke. But I'm not sure that's what I meant. I was actually saying that we can develop vocabularies to represent that. Now there's a couple caveats to that. The first caveat is that we don't know everything that's in food. We're still finding molecules that are in all kinds of food. If we look at milk as an example, the International Milk Genomics Consortium conference just finished, and there are reports of new discoveries of oligosaccharides. There are reports of new discoveries of bioactive peptides, of milk fat globule membrane sizes, different bioactive aspects to some of those components. So you know, as Neil deGrasse Tyson says, as the island of my knowledge grows, so too does the perimeter of its ignorance, right? So we can only characterize things as well as the information that we have. The second aspect is particularly regarding where the organoleptic, now some food scientists would argue that essentially there is no reality, only perception when it comes to food, and that the food doesn't have properties, but that there's an intersection between you, the food, and the environment. And to a certain extent, they're right, in that I can, as a for instance, put some red food coloring in a white wine and tell you it's a red wine, and I may be able to get you to say that you can taste tannins because I've tricked you. I can get you to report negatively on a food if I don't let you go to the bathroom for several hours before you eat it. There's lots of things that I can do to bias your judgment of the food. But that said, if we bite into a mushy apple and it doesn't crunch the way we expect it to, I can call an apple a mealy apple. You could probably agree it's a mealy apple, and a bunch of other people are going to agree. And then at that point, I say we can assign a property to that apple that's a mealy apple. And we do this all the time with Q&A in food. So there are sort of you know, at a philosophical level, no, it'll never be complete, but certainly we can come to agreements. Now, and there are other aspects around culture that we use different words to describe similar things, and we use the same word to describe different things. That becomes tough as well.
Well, I appreciate that you had the temporal aspect, because everyone that knows lasagna knows that lasagna tastes best on the third day So you always make a huge lasagna, and the third day is when it's actually at its prime.
Well,
sorry.
You know, lasagna is a particularly funny one, and it's in there on purpose because it's just about the most complicated thing, right? Like you can throw a bunch of stuff in there and call it a lasagna. In fact, when I met my wife, who is Italian she's from Milan, Piemontese, just outside Milan, and not long after we first met, we were asking each other, oh, do you cook? Do you like to cook? And she said, oh, you cook? I said, yeah. I said, actually, I make a vegetarian lasagna. And she said, I've never heard of such a thing. and I said, yeah, it's got carrots and onions, and I chop up some almonds and put it in there. And she said, well, that may be good, and it may be a lot of things, but that's not a lasagna. and so there are these cultural definitions where what one person's lasagna is not another person's lasagna.
And I'm going to jump in here. So Bill will have one or two things to say about vegetarians' lasagnas, but I wouldn't invite him to say anything right now. We actually have two other questions lined up. But let me jump in and maybe ask you one question, which I've actually got two questions. I'm going to throw the second question off to the nether because it relates to scalability of ontologies. I'm going to go to the first question, which is somewhat more tractable. But before I go to my question, a quick comment. Matthew, you mentioned that you had checked out that you saw something related to corn at George Mason University. There was a resource on ESIP. So the PI for that work is actually online. His name is Ziheng Sun. Well, if you scroll down the list, it's Jensen, Jensen, Ziheng.
Yeah.
So Ziheng, and Ziheng, if you're hearing this, I would invite you to jump in at some point in time. But and the other comment that I have is, so the Agriculture and Climate Cluster has been working actually recently on Sustainable Development Goals. We were trying to parse some of the SDG targets. SDG targets were kind of amorphous and they were not very succinctly defined. So we were doing a manual semantic parsing of the SDG targets into terms that are defined in ENVO, food on, and so on. And so I was pleasantly surprised to find that you have been working actually with Pierre Buttigieg. But my real question is this: it relates to food sheds and what you were saying. Dan had said that he was glad that you took into account the space, the temporal component. But the question I had to ask you is about on spatial components, because when you mentioned food sheds, that immediately brought to mind, of course, watersheds, and at least in the environmental / ecological / earth science arena, watersheds are analyzed at different spatial scales. The USGS has got something called the HUC level, and so it has been useful. For example, very large watershed scales to analyze certain processes at those large scales. For example, the Colorado River Basin, that's one large scale. But at the very same time, we also have utility in analyzing processes at very fine spatial scales, like in your own backyard, that kind of scale. And so that brought up a question in my mind in relation to what you mentioned about, organizing your ontologies, I guess, if that's where I put it, according to phenotype processes, agents. Now, how do you see, kind of on a different dimension as what Dan asked you about temporal scales, how do you see spatial scales maybe working into the phenotype processes, agents, that in that hierarchy that you have spelled out? And I'll shut up and let you answer.
No, that's great. We actually do a lot of work with that. Now, that's not my particular area, but the Food Systems Lab, formerly the Tom Tomich, who leads the Food Systems Lab at UC Davis, essentially with his core team, their expertise is really in geographic information systems and display of information. And so we, I'm trying to think of the tool. It's gonna come to me in a minute. But we do a lot of use case planning, land use planning with the data that we're collecting. So looking at trade-offs between open space and ag development, what have you. So MarxAN, I think, is the tool that we use, MARXAN, for essentially weighting various decisions that can be made around land use. That's probably the most that we interact, is looking at sort of the interaction between land and food production, would be those land use decisions that get made at a regional level. So certainly I am familiar with the HUC and the various. In fact, we were having the conversation just the other day with various ways to represent geographic boundaries and whether certain districts have control or influence over those boundaries. I guess it's worth it to tell you that we haven't sort of publicly announced it yet, but we are also developing ontologies around not just food systems actors, but power and participation and influence, to understand how these actors interact with each other and how decisions get made related to food. Does that answer your question?
Partially, but let me maybe move on to the other
Okay.
speakers, I mean, the other guests who have questions.
Sure.
If I have time, I'll come back to you at the end.
Okay.
But we should maybe go on to the two questions. Bill, do you want to queue those up?
Yeah, well, there's only it's one now because Talia said her question is already answered. But so Lindsay Barbieri has a question for you, Matthew. Her mic is not working, so I'm just going to read it. So she's curious about the part of the title, the title of your talk that says existential threats to established actual hegemonies. Can you elaborate on what you meant by that? She was very intrigued by both what you felt was the hegemony in ag and food and what you think of as the existential threats related to your work.
You know, I probably should have covered that a little bit more in my talk. I was a little bit worried about running out of time and not leaving enough time for discussion. So thank you for asking that, Lindsay. I really appreciate it. COVID has laid bare a lot of the problems with our food system. We've seen that food system workers, whether they're in restaurants or working in the fields or working at meat packing plants or meat processing plants, as all four instances that have been in the news, these are often the most vulnerable and the least protected workers exposed to a virus, right? So, so we can look at that and say, okay, on the one hand, there's these threats to the food system, and as a result of COVID, we've got, you know, here in Sacramento, which claims to be the farm to fork capital of the country, farmers plowing their fields under. Even before the restaurants were going out of business, because they didn't have markets to get rid of their food. And we're talking the best food. This is the best food. So access to supply chain, access to value chain, being able to pivot, being able to have an information infrastructure that allows actors in the food system to pivot, that's one aspect. Workers being exposed is another aspect. And the third one, which I think is where we'll really we've seen cracks, is that if we look at sort of the beef industry and meat processing as an example, we had entire the cost of meat went way up, and we had entire facilities closed down, which caused the price of meat to go way up. Well, they closed down because of COVID. So what we've seen is that as we've centralized resources, and I should have put this one in, but there's a great slide, some research that was done recently that, you know, the number of acres under plant in the United States has gone up slightly, but not that much. But the number of farmers has gone way down, and the number of acreage per farmer has gone way, way up. So we've centralized the power in the food system. That also means we've got more single points of failure. And the meat industry is a really good example of that. So while I'm not covering it in the slides, I hope I'm covering it here to say that you know, these centralizations of power in the food industry represent single points of failure. That's a problem. So I alluded to this in my slides when I said, look, we aim to democratize the food system and to make the food system more distributed so that there aren't as many single points of failure in the food system, so that there is more food equity, and so that we lower the barriers to entry for people who want to become part of the food system, to be an actor in the food system. And I think when we do that, we are transforming the landscape. Now, that is an existential threat to the centralized powers. The democratization and distribution of the food supply is an existential threat to those powers that be. There are other, threats that happen if we start moving towards an integrated food system and information can be spread rapidly. Well, I think we've seen through social media now that when it's misinformation, that can be catastrophic. I tend not to say this in public too often because I don't want to give people ideas, but I don't have to actually poison the food supply to cause a panic. I just have to convince you that it's poisoned. So I'm working on a paper with a colleague right now. We've identified, I think, close to 200 potential threats to the food system as we wire it up. As the food system becomes more digital, there will be more threats that exploits that people can take advantage of, and we need to design that. And we all saw what happened with Internet of Things when security was not first. So security needs to be a big part of this, and we need to be thinking about that constantly as we build it up. I hope I answered your question. I have the chat window open now, Lindsay. So if you have any more questions, feel free to follow that up, and I will just read it.
Matthew, I guess jumping back to a point that you made earlier in our presentation, we are running out of time, but let me just mention this very quickly. Your mention of democratization and also security issues around food, of course, was relevant to one point in your presentation when you talked about blockchain technology and how then maybe a technology to help, for example, if we have another situation where, the middle persons in the value chain are knocked out because of events. If you had blockchain technology set up and the appropriate infrastructure set up, you could connect the producers more directly to the consumers, cutting out the middleman, because that was one of the objectives of blockchain technology.
I think that I don't know what it looks like yet, but I'll tell you that I am actively exploring peer-to-peer file systems, not just blockchain, but peer-to-peer file systems that essentially record transactions of the file system in a ledger in the same way. So ledger-based systems that allow for peer-to-peer interactions, I think are absolutely going to be part of this and fundamental to reducing single points of failure, to enabling access coming in at any point. And actually, the internet started off with this idea that we were going to democratize information, but what we've seen is a massive consolidation of power and information asymmetries. As a result, now we have 6 shopping malls on the information superhighway that control just about everything, and I think that the information superhighway can have a lot more on-ramps and off-ramps and be a lot more diverse and glorious, especially the information superhighway for food.
So I have 4:01. So unfortunately, we ran out of time. This has been amazing for me. It's like really open up the thinking process. A lot of things I haven't thought about before. I actually have a short list of questions myself, but I'm gonna save that afterwards. I'll follow up with you, Matthew.
Okay.
But before we sign off, does anybody have like a very quick question that they just like can't wait to be answered before we conclude?
Yeah, especially somebody like Ziheng, if you have questions for because Matthew had raised your website, your work. If you have any comments, this would be a good time to speak up.
Okay, I mean, it did sound like it's something that could be easily, well, in Matrix, it's an easy, could be easy win. So something that may be a collaboration potentially there to
I think that would be great. I've looked through the resources on your sites and some of your affiliated faculty members like Ziheng, and well, I think that would be Fei Chang Hao. It would be fantastic. It would be great.
very nice.
It would be really, really great. So yeah, if we can, I would love to explore that with whoever's the appropriate person to explore that with.
Okay, so we're 3 minutes after. I know people have other meetings to go to, and I also have one myself. So thank you again, Matthew. This has been amazing. I definitely will be following up with you because I have so many questions.
Oh, cool. Thanks.
Yeah.